Hi, welcome to SQL in the City Streamed. I'm Steve Jones, and I'm here to talk to you how to create, protect, and manage your databases for compliant DevOps. Now, I've been working with SQL Server for a long time, over 26 years with SQL Server alone, and in that time I've been a DBA and developer and manager and speaker and writer and all different things for different companies, different industries across my career. And I also founded SQL Server Central. And so I've spent a lot of my last decade here working with SQL Server Central, trying to help you become better at your job every day. And I do work for Redgate as an evangelist. Redgate owns and sponsors SQL Server Central for the community, and I'm proud to actually be associated working for Redgate Software. And Microsoft recognized me as a data platform MVP for the last 10 years, which is pretty cool too. I'm honored that they have chosen to recognize me. But today I want to continue to talk to you about data compliance and how you build software. Now, the GDPR is coming into effect this year in 2018, where it's going to start being enforced by the EU. It's on a lot of people's minds. Certainly we here at Redgate are concerned about that. But we have to still develop software. In spite of anything we have to do with GDPR, we have to continue to release software. Microsoft has continued to work on their software. Plenty of you are in the same situation. As we move forward with our software pipeline, our development, our delivery, we have to think about a number of things. For example, what data do we process and how do we handle all of the data that we have? That's certainly one of those components of the GDPR that everybody has to be concerned about. And we need to make sure that we understand where all this data lives and then classify it. We need to be sure that we understand what's sensitive data, what isn't sensitive data, which data will be subject to the GDPR because it's sensitive or personally identifiable, et cetera. And certainly we have to worry about access controls. Who can access our data? Who can see an email address or some other information that might be considered personal for somebody else, for a data subject. And then we have to demonstrate that we're actually doing this. If somebody were to complain, if a regulator or an authority under the GDPR were to want to check, we have to demonstrate that protection. And here at Redgate, we've been working on solutions to help you go through this whole cycle, right, of discovering your data, classifying it, protecting it, and monitoring it. We're trying to help you move from that phase of just telling what you're doing or trying to disclose it and talk about it to actually proving it and showing anybody that's an authority, a regulator, a government, even a data subject that may request information. We want to show that we have compliant processes, that we are taking care of your data. And really, one of the key factors is that we want to move into a DevOps world where we have a repeatable, reliable, consistent process. The DevOps have been hot. I've been talking about DevOps for a number of years. Many companies around the world, especially technology software companies, are talking about it. And I think this definition from Microsoft is actually one of the best that I've seen. Now, Donovan Brown came up with this and he wrote it and saying that really DevOps is not a specific thing, it's not a tool, it's not something we buy, but it's this union of the people that we have working, the way that we do things or the process, and then whatever tools, platforms, software that we're using to deliver value to our end users. Now, a lot of people think that's just what developers do, right? We certainly deliver value to end users, but we want to have this continuous delivery that it works at the pace or the speed that we need it to work. So we've got this great little icon you see on the slide where it's kind of a circle that we have to go through this process. It's like a gear. We have to certainly build our software, we develop it, use automated building or some way that consistently builds it, test it, package it up, release it to users, continue to monitor it, protect it with backups or any other way that we need to do for software or for servers, and provision new environments and then repeat the process around. And that's really what DevOps is. It's a circle. We can constantly go through the process of building software, releasing it, getting feedback, understanding how it works, making new changes, continuing on. Now, as part of DevOps, Redgate really tries to ensure the database is part of your process, that we want to make sure the database goes along with all your application software. And so we want database DevOps success in however we build our software. We don't want the database to be separate or one-off. It's included with anything else we're doing. And today we're going to talk about provisioning those dev and test environments because we do need databases there. We have to give developers something to work against, testers something to work against, potentially clients something in a user acceptance or beta or other form as well. So we want to cover certain parts of this process. And for me, today I want to talk about provisioning, which will go into my development and build areas and certainly testing areas as well. These environments where I want to provide databases, I want to have these separate set environments or separate setups that each different group can use, but still do it in a consistent manner. We want to do it in a way that protects and preserves our data so that any sensitive data isn't exposed to anybody that's not authorized. Certainly we don't want it released from QA or dev environments, which has happened in a number of data breaches. And we want this to be a continuous process, one that's iterative and one that improves over time. Now, when we look to provision databases, and many companies I've worked for, that can be a blocker to DevOps and compliance in some ways. Certainly the time effort can block DevOps, that the time it takes to copy those databases around, to deal with just the amount of space that I have to deal with as well, and provision disks and have that, to kind of manage the sprawl as developers want different copies or different environments, such as a CD environment or CI environment, a QA environment, as they need copies as well. We have all these issues around trying to move fast in a DevOps fashion. We also have security issues. We don't want to release data, or we don't always want to have that production data, that sensitive data like credit card numbers or emails released into dev and QA environments. We may trust our developers, but staff can change, that other people may look at those environments, that we may not have the security we want in those environments, so we don't want to move that data outside of production. We also don't want to work with just one or two environments. One of the things we found over time is that having individual environments for different developers or for different situations, such as QA or testing or CI, actually prevents conflicts, that anybody can move as fast as they need to without impacting other groups. So when we have shared environments, that's a problem, that everybody has to be on the same page. We have to decide that if I need to make a change and Grant needs to make a change, we don't conflict with each other. So provisioning separate environments helps to smooth out that process. And if we can't do that, that becomes a blocker. And then of course there's limited testing. Often we find if we're not moving sensitive data around because we want to protect it, we'll have to build our own data sets into development environments or into test environments, which means that we can't fully exercise the application in the same way we might in a production environment, or the same way that our users will in a production environment. So if we don't have a smooth, compliant DevOps-style provisioning process, we're blocked by all these things. So I want to take a minute and kind of demo something. Last year we released SQL Clone, which I think is a fantastic product, and I really wish that I had had this earlier in my career. But it's one of those tools that really makes provisioning really very easy. So I want to show you a quick demonstration here. So if I look here in Management Studio, I've got kind of a script of things I might do as a developer. So you can see that if I run this query, I see some different items in here, and you'll notice I've got a bunch of different prices. And part of what I want to do here is I want to test some different things in my application. So I want to test a particular item, but I'm moving fast, it's almost lunchtime, and I'm in a hurry, so I'm not always paying attention. I find that, even as a developer, when you have headphones on, you're trying to focus, sometimes you get distracted, you're in a hurry, you're going through the same process 50 times, and as you're doing that, sometimes you'll make mistakes. And so this is the kind of mistake I see people make all the time, where I'll forget this where clause up here, and then what will I do? Well, I'll affect my whole data set, which is not what I want to have happen. And in fact, if I go back to try to do other work, what I'll see is now everything's the same price. So maybe that affects me, maybe it doesn't, but this isn't what I want in my data set. I want a variety of prices. So if I'm trying to test different things like discounts or quantity alterations or something else, I want to have different prices in there. So that's a problem. Now, if I haven't backed up the database, I can't restore it. If I don't have an easy provisioning process, this is a hassle. But with SQL Clone, we make this really easy. I've got this clone here. I'm just going to delete this through the interface because I have the rights to do this. And then I'll just recreate another clone. Now, I haven't touched Management Studio here. It's still connected to that instance of SQL Server. And once this deletes, then I can create a new clone that will reset my database back to where the image was. In this case, let's grab the correct instance on this machine, and we'll put back that same database name and create this. Now, I could do this with PowerShell or in some automated fashion. As a matter of fact, if I look at my clone, you'll see that I've got examples of how to create a clone or create an image here. I've got all the PowerShell, so I could automate this. But in this case, I just did it through the GUI. And let's go back to Management Studio, and I'm just going to rerun this query. And we'll see that everything's put back the way it is. We essentially did a reset back to the way that that base image was created. And as a developer, I have self-service to do that, either through Powershell or through the interface. But I can very quickly test things out. I can do my experimentations in development. And if they work, great. If they don't work, that's fine. Either way, I can reset my data back to a known starting point here. Okay? And I can continue with my development. The SQL clone makes that really easy, and it's a fantastic product. And it helps us with some of these conflicts that we have when we try to build software. That developers and our software teams want to move faster. And in order to do that, they really do need up-to-date, realistic data. Something that looks like production, something that they're familiar with, or at least will exercise the application the way they expect it. And they need to get those copies of the databases on demand. So if I need to branch off to test some new feature, or I need to branch off to do a bug fix, or certainly in the GDPR case where I may need to do a security fix, I want to have another copy of that database that I can look at. And SQL Clone makes that really easy. There's other ways to do this, but none are as smooth and easy, I think, as SQL Clone. Certainly not with that value. But while developers want to move fast, DBAs want to move slow. And it's not because we really want to move slow, but we need to protect the copies of the data that are out there. So I need to know where all the copies of my databases are. I don't want developers, I don't want QA, I don't want build systems randomly restoring and creating databases without my knowledge. Because ultimately, if there's an issue or there's a release or there's a potential for a problem, I need to know where all the copies of my data are. And maybe more importantly, once I leave production, I really want to sanitize data. There's no reason to use real credit card numbers or real tax ID numbers often in development or test systems. So I need to protect that data. And because I want to protect it, sometimes I try to slow down the process. We want to show you that that doesn't need to be the case. Why do we care about this stuff? Well, throughout SQL in the City streamed here in March 2018, we're talking about GDPR and the fact that regulations are becoming a bigger issue for us. Now, certainly some of us have had HIPAA or PCI or SOX or other regulations in the past, but the GDPR is really a more severe regulation. It is increasing the fines and it is increasing the rights of the people that the data describes. So not the company that may own the data, like Redgate, we have your customer data, but you customers have rights against the data that we hold, and that's a big deal. And it's not just the GDPR. There are certainly other regulations taking place. Japan, Australia have regulations in the works. The NIST draft regulation in the US may become a law at some point. But the idea is there's just an increasing tide of these laws and legislation that are going to apply to those of us that handle data, especially those of us that deal with personally identifiable data. And there are certainly other industry requirements as well. In the US, the SEC and FTC are constantly adding new requirements because we find new issues with digital data and new ways that people exploit data or certainly hack into data. And so they're constantly updating these regulations. So we've got to be prepared to adapt and respond to any of those changes. And fines are increasing. The reason they're increasing, the reason we have prison time, if you watched Grant's session from this stream, you'll know it's because data breaches are on the rise. It's kind of the new normal, which is sad. But if you look at this graph, you can see across the last few years, the number of incidents are just growing and growing and growing, and the number of records exposed are growing as well. It doesn't look like it's going to get better anytime soon. Now, we did a survey at Redgate. We're very interested in database DevOps. We want to help you solve the problems that you have with building against databases, certainly in all of your development process. And what we find is that many of you want to use production data in your systems. A majority of you use a copy of production in some part of your systems, which is never good, especially if they're sensitive data. At least half of you do some masking or subsetting or something in there, which is good. That's good to see, and we want to see that. Though if it's subsetting and not masking, it's not necessarily the best case, because then I'm not testing the scale of my application, or maybe not testing all the edge cases I have with data. Though certainly that's still better than nothing. Now, some of you synthesize or manually create data, and I know a few of you do this. And I understand why if only a few of you do this, because it's a pain, it's a project in and of itself, and you often only exercise a subset of your application, and you pick the data that you think satisfies your happy path, that meets the requirement that you're trying to create. And so it's a minimal amount of data, and it often isn't effective. So you rather use production. As a matter of fact, that's the most common thing that people want to do. they think that production data is really important in dev and test environments. The majority of you agree with that, and only a few of you disagree. Now, I think the scope and scale of production data is important, but the actual production data, I think, is problematic. And certainly, it becomes an issue in the GDPR or other regulation, because if that data becomes released, then we're responsible for that. Ultimately, what the GDPR asks us to do is do what they call data minimization. Now, this isn't about deleting a bunch of data to reduce the amount that you have, though you certainly could take that approach. Really, it's asking you to only take the data that you need for some purpose. So we want the minimal amount of data that's useful. That could be the full production set, it could be something else. But we have to disclose the process, be transparent about why we have data and what purpose it's used for. So we only want the data that's useful to us or that we have built an application for. And then we want to reasonably limit the chance of any disclosure of this data, which often means we need to do something about that sensitive data once it leaves a production environment. Now, we think at Redgate one of the best approaches here is to sanitize this data somehow, whether that's trying to de-identify it or pseudonymize or pseudonymize, I think is how I'm struggling with that word, but I want to some way try to anonymize that data, or as closely as possible anonymize it, so that it's useful for my non-production environments, but it doesn't relate back to an individual, or it isn't the same sensitive data. I haven't disclosed a person's real tax ID along with their name, their birth date, their credit card number, their tax ID, their email, anything that might be considered sensitive. I've somehow sanitized that for non-production use. So I still have the full data set, I still have things that look the same, but they're not related exactly to that person. Maybe I've adjusted sales amounts or invoice amounts or dates or something slightly in a way that does a better job in obfuscating. It's really, sanitizing that data, so it would be very difficult for somebody to figure out what the original data set was. And so I'm excited that at Redgate recently we acquired a product, a data masker for SQL Server, and we've done some work and improved it and then re-released it. And I want to show you how this works. I think it's kind of a fantastic little product. So here's the data masker for SQL Server. If you look here, I've opened what we call a masking set, which is a set of rules for kind of changing data around. And this is really a fantastic product. The more I use it, the more that I'm excited about all the features and capabilities. That it allows me to really solve any sort of masking need that I have. You can see here I've got what they call a controller, which is just kind of the overview of this whole process. And what it does is it runs a series of steps in order. So I've got, I disable and re-enable triggers, which often I need to do if I'm going to sanitize data. And then I have a bunch of rules that I put in the middle here, substitution rules. For example, you'll notice here, this first one, I have a description that says change female names. Well, let's look at what this rule is. What this actually does is it goes to my customer table and it takes these columns, the first name, last name, the company name here, and then the telephone number. And I'm going to change them with some data set. For example, here I'm going to take first names, and the data set that I've actually chosen here is the names of females. So if I come up here, it's actually this female name list. And so I'll replace all the rows here with the female names. And if I wanted to see a sample of what names are in there, I can see that. I could look at the column data or anything I wanted to do. And so this is one of those rules that's going to replace all my names. And if I step out of here for a minute, let me go show you this in Management Studio as well. So here I am, let's execute this query. You'll see that I have different genders of customers and I've got different names here. So maybe I'm not always sure of the names being correct, at least not for my American English centric world, but I assume that's a male name. These are female names. Freddie, you can see I've got a number of names here. I'm going to replace all these with female names. Right? That's the first step in this rule. And I can easily execute this to see how this works. So let's run this. And once this runs, what I'll see in my statistics here is I'll see 100 of these ran. I replaced data in 100 rows, and I know that I've got 100 rows in there. And so if I go back here and look, let's say we had Gerald and Gaylord here for 3 and 4. Let's rerun this query. So you can see that Exie and Roxy now become the names. And really, if we scroll through here, it seems like most of these names are female, at least from my perspective. Deborah certainly is. We've run this one rule and replaced things. At the same time, we've also done the last names, we've done the company and everything else as well. So let me go ahead and make a vertical tab group here so that we can see this. We'll assume that we've got those names over there and over here. Let's pick this query. So let's scroll this over so that we can see this. So as I make a couple changes, you can see what's going on. And over here, we'll show you it's the same data set. So I'm connected to the same database here. So in my data master, I do other things. Now here I've indented a rule, which means it's dependent upon a previous rule. So as I'm examining my databases and I'm classifying all that data, I have the ability to add different rules that will slowly mask out that data for me. For example, this second rule, if I look at this one, let me just come back over here. In this case, I'm replacing the first names with male first names. If we see the top pop up here, but I'm only going to do it for certain rows. In this case, I can just write a T-SQL where clause and only replace those rows where it's a male gender. And I have various other options in here. I can certainly add a description, like I should have this say male name replacement. These days we have gender neutral and other designations as well. So by picking some logical way to replace names, I can ensure that the data set is still useful and valuable, but it isn't necessarily identifiable because I'm replacing this data. So in this case, as you can see, I'm replacing the male names, and if I were to run this one now, just one rule, I can let that go through, and when I look at the statistics, what I'll find is it's replaced 50. And I know in this data set, because it's a demo data set from us, and it's a good one for you to practice with, there's 50 males and 50 females in here. So now if I go back and on this query, let's rerun this one. Remember on the right, we had the original data set. On the left, we have the new one. You can see that Cardad has become Percy, right? Didn't replace the last name, just replaced the male first name. So all of these females are the same. And then we come down here to the males, we see Keenan and LeVar instead of Deborah and Yasmin. Or sorry, instead of Rena and Deborah. So as I decide I want to mask my data, as I find ways and identify sensitive data, I can build up a set of rules. And you can see here I've got a number of rules. Some of them are dependent on other ones. Some of them are separate ones. In this case, I'm going to a different table. And I have the ability to just build my masking set over time in a way that allows me to customize this for my particular environment. And it's kind of amazing because as I've done this in the past, and I know many of you have built your own scripts, we find this a very complex process. And as I try to handle this, I build bigger and bigger scripts that are hard to maintain. And Data Masker makes it really easy, and it works in a very logical fashion. For example, if I wanted to create a new rule, I pop up this list, you'll see that I have all different types of rules. So I've been using substitution rules, which substitutes one set of data for another one, okay, and that replaces it. But I have the ability to shuffle data. So I could shuffle existing data in a column between rows. So if I have status or if I have something like that, I have the ability to kind of mix up this data, which is something that is a little bit complex for us to write in T-SQL, but we make it really easy here. We can insert new data and do searches and replaces. But these synchronization rules, I think, are some of the most fascinating ones. So my row internal one allows me to synchronize a column with other columns in that row. Why would I do this? Actually, I have an example. So this next one is a row internal rule. And this one actually is replacing the email. Let me zoom in so we can see this. In this table, in this column, which is the email column, let's go back out. What I'm actually going to do is I'm going to use a couple parameters here. For in this case, what I'm going to do is I'm going to take the first name and the last name. And in this case, I'm only taking the first initial, and I'm going to build a new email address. So I have an @ and then I use a couple parameters here. So in this case, I'm taking a random set of dictionary words, which if we look at that, they're just words from the dictionary. And then I'm using this random SLDs, which are just old domains. Now, I've worked in the email business for a long time, and I've had many applications that send email. And one of the worst things we can do is in a QA or dev environment is to actually send out emails to customers that we're testing. And we never want to do that. So I often want to have dummy email addresses in there. And this allows me to kind of customize exactly what I want here. So for example, if I were to go back and manage this video and look at this, you'll see that in the original data set, I have these emails, right? I have mu.tl.ij, btq34. I've got various email addresses. What I really want is these to correspond to these names, so they look real in my application, even if they're not the real addresses. So let me change this rule and we'll actually run this. So let me change this and remove the substring so we can just see how this works. And then I'll put it back. So in this case, I'll just update this rule. And if I were to run this rule right now, instead of my statistics, I should see 100 rows updated, and I did. Here's the original set. Let's scroll over here. Make sure we're at the top. Similar here, right? But let's rerun this. Now what do I have? Well, it's much different. And in fact, it corresponds to the data I have over here at first name, last name. So we'll see that if I put these together a little bit, these two columns have been used to generate that new email address. And I could certainly do anything I want with this, right? If I need to change it, and let's change it back. I can do that. Any format that I need, I can add that. And if I need other parameters, I have the ability to do that. I could add one here. And I think one of the most powerful things about DataMasker is building up sets of data. For example, if I needed bank account numbers, here are bank account numbers from New Zealand. Right? I'm assuming the National Bank of New Zealand. But there's the options here. I could pick a specific bank, I could format it, I could do whatever I want. And we've built across the years all these different data sets. So if I needed credit card numbers, we could do that. Pick which kind it is, if they're visas. If I wanted to pick a date, I have the ability to vary a date. So if I have a date column where I'm shipping data or I'm shipping products or something is due or scheduled, I can move the variance around in the date and have it say, let's go plus or minus a certain number of days from the original value. And certainly 0 could not be a not valid variance, right? That I don't want to ever have the same date appear that originally was there. I've got all different kinds of things. It's kind of amazing what's there. I've got name lists, I've got telephone numbers, I've got nationalities, all different kinds of things. And even random text. So in that case, I used the random text, so just dictionary words to reformat the email domain, but I could pick anything I wanted. I could pick countries, I could pick something else that would just appear. We've got banking codes, IP addresses, and everything else. And for each of these, we allow you to pick and choose how you want to format it. For example, one of the things you might want to do, actually I want that, I want zip codes, I think. We can have you create real addresses with random numbers and street names, but real city, states, and zips that would match up in your application. So if you're building software that needs to ship out to real addresses, you can mask the data and change it to be whatever you want. I'm going to cancel. Actually, I want to delete this row because I don't want to mess it up. I think everything's good. Let's update that. We have all other kinds of rules, right? I can not only sync between columns, I can sync between rows, I can sync between tables. And if there's some rule that we don't have here, and we do try to give you some kind of guidance here at the bottom, we have these kind of basic general rules that allow you to put in any T-SQL command that you'd want to put in there. So you have the ability to customize this however you want. As I've been working with this for the last few months and I've tried to think of different cases, I haven't found one that I couldn't handle with this masking. I think it's incredibly powerful that I can build this up and make it really easy. Now I've done this thing manually in the past and some of you have as well. You think, well, I could just do this, and that's true, but what about if you leave? What if I have to give this masking process to a junior DBA or a junior developer and say, I need you to modify this in some way? It becomes cumbersome and difficult, and DataMasker really makes it much easier to do. I save these sets as files out on the share somewhere or on a shared server, and then I can call them and execute them as needed. And developers can pull them up, they can run them from the command line or automate them, but it's a really powerful way of kind of protecting your data outside of those production environments. If you haven't given it a try, you should give DataMasker a try, and certainly if you've got some edge case you think won't be covered, let us know. I'd like to help you solve it and figure out a way to do it. So let's pop back over here. I've talked a little bit about clone, and I've talked about some data masking, but let's talk about provisioning in a compliant way. Right? So I want to put all this together. Ultimately, if I'm trying to build a DevOps software development process and I want to move fast and quickly, but be secure and have a consistent process, I need to do a few things. I need to understand where all my databases are for sure. That's definitely a part of the GDPR, is understanding where your data lives and which of it is sensitive. And then I need to have some way to make it easy for people to create, access, and work with the databases that are out there. And that's one of the things that is important to do. I think we've got a great solution in SQL Clone, but however you want to do it, you need to make sure you have some control over there. Then I need to clean up that data. Now I've shown you SQL Data Masker, or Data Masker for SQL Server rather, which I think is a fantastic product for doing it. But whether you want to do it with your own scripts or something else, you definitely need a process that will allow you to take sensitive data and protect it. Right? Part of the GDPR is that I minimize the kind of scope and surface area for all my data that could potentially be released, and having it sanitize or change when it moves to non-production environments is one way to do that. Then of course I need a kind of consistent process to do all this. Hopefully it's automated, it allows some self-service, it allows developers to work, it allows everybody to move as quickly as possible or as quickly as they need to, but also includes some kind of audit process that tells me whenever I've executed something. And we do that as well, because we need ultimately a record of all the activities we take in the event that we are audited, that somebody checks on how our data is, or in the worst case, that we've actually had an incident where we've lost some data. So we need to kind of go through all this to have a compliant provisioning process. And at Redgate, we've tried to build solutions to help you out. So SQL Provision is a new bundle that we announced recently and launched, and it combines SQL Clone, which I showed you earlier, and Data Masker, which we just looked at, together in one bundle to allow you to take those production databases, mask, change, sanitize, control them, and deliver them out to your developers in a way that allows them to still work as quickly as possible. It allows them to build environments as needed, separate from each other, and develop their systems. It allows you to do the same thing for QA, for testing, for client access, user acceptance, any other environments that you need to. And that's what we're trying to do, is make this easy for you to create, protect, and manage your provisioning of databases. Now, some of the benefits that we've got here, really, Clone provides a huge benefit by virtualizing our data. In that first Clone database, that was a gig database, which is very small. I realize that, though, just on my laptop here. But it took much less space, saved a huge amount of storage space. So even if I was doing a backup and restore, even as a developer, if I was consistently able to backup and restore, I'd use a lot more disk space, which sometimes isn't manageable on a laptop. If I've got a terabyte or 2 terabyte or 10 terabyte database, I don't know that my boss wants me to buy the $5,000 new 30 terabyte SSD. Chances are I'll have to cut down that data set somehow. And if there's multiple developers, that storage just grows exponentially. And we certainly want an isolated environment. And certainly, if I've virtualized the entire database, if I've virtualized a terabyte or 2 or 3 terabyte database, then I can test using realistic data. And in my original clone, let me show you that one that I had. This is a 1 gigabyte database. Let's scroll in just a little bit lower. Here it's a 1 gigabyte database, but on my machine, I'm only using 75 megabytes. So that's a substantial savings. And really, the size of that clone is always going to be in the tens of megabytes, even if that's a 5 terabyte database. If you go back and watch from our launch, I think in December we did SQL and City Streamed. I did a session on SQL Clone back then, and I was using a 4 terabyte database that was stored on a share here at Redgate. But on my laptop, I built that with just less than 100 megabytes of space. And what's more important is that the time is about the same. Whether I build a 1 terabyte clone or a 1 gigabyte clone, it's about the same amount of time for me, which is huge savings as a developer. Provision also with Data Mask allows me to protect that data, that I can ensure that I can mask, anonymize, randomize, change the data in some way, right? Move dates left to right, move values up and down, allow me to ensure that none of my sensitive data actually makes it back to a development environment, never makes it to a test environment. never makes it outside of production if that's not what I want. And I can do that at scale. And the data masking ensures I have that consistency, which is very important. Now, I showed you through the GUI how to do this, and in a minute I'm going to show you how to automate it, because ultimately the power of DevOps and the speed of DevOps comes when we automate things. DevOps is about doing things better, being repeatable and reliable. As soon as I know how to do something and I want to repeat it over and over again, I want to automate it, which is fantastic. It allows me to move quicker, and more importantly, it frees up my staff, because I don't need those provisioning requests as often. I don't have to bother the SAN admins to say we need more space for databases. Developers don't have to bother the DBAs to say, can you make me another copy? Everybody can do this automatically. Especially with something like PowerShell, it becomes easy to script and alter this for different types of environments and include it in build processes, right? Whether I'm building, or I'm deploying, or something else. And then lastly, because I have a central location to view everything, I can manage all these copies and I can see where they are. Clone gives me an overview of all the copies of my databases that I'm using outside of production. So this is all for test and development systems. I can see what's going on. And more importantly, any of the actions I take with something like Data Masker are logged. I get reports and logs of everything that's changed. I can verify that every record was changed because I get a summary report, and it becomes very easy for me to go to an auditor and so all this data that came from production has been masked into the image. And of course in Clone we do have some role-based permissioning, and I'll show you that as well. So let's take a look at some of this provisioning. So the first thing I want to do is I've actually got a PowerShell script here, and I'm going to run this with just one command. And if I go over to my dashboard, what I'll find is this is going to actually delete out my old clones, as you can see them disappearing now, and it'll delete my image, and it's gone. And now what it's going to do is it's going to go back to my original database, and it's going to build a new image. And it's going to then mask the data in that image, and it's going to build me new clones again. So we can see the process going on. If we wanted to watch it, we could go look at it in more detail. And it's starting with that Data Masker demo database. I can see where the image is going. And I have some auditing here, some minor metadata in the GUI, but I have more available in the logs that are occurring. And I can see the process though. Am I building this image? And that's building my clones now, but you can see I've got other images as well, and I can see the various clones that have been created for any of them. So I'm always aware of where my data lives outside of production. I know its source, I know if we've masked it. In this case, you can see I've got this lovely modified tag, which tells me that I've masked it, and I can see what's going on. And we made this integral. So I'm doing it in PowerShell, but if I were to do it in the interface, this is what I would see. So I would pick an instance, and I would pick a database, and then we have this ability to mask things. And you'll notice it says it takes masking set files or SQL scripts. So I could drop in any SQL script that I'd written myself, or I can pick a masking set file. I could drop it in here with drag and drop, or I could pick it. In this case, I have a data masking set, but if I happen to have, let's say in Management Studio, some kind of script, I could pick a SQL script as well. And what would happen is it would apply this when it's masking and creating the image. And then I give it a destination and say go. I do that same thing in PowerShell. It looks kind of like this. So I set some variables. I remove my old items, which in this case, because I'm rebuilding that image and rebuilding that clones I need to do. Here's how I create a masked image. It's really one command here. And we've added some new parameters. So I've got a modifications parameter for masking sets or SQL scripts. And then I create new clones. In this case, you can see I created 3. One, I have the variable above, and one for Grant and Kathy. And if I look in Management Studio, I should see all of these. So here's the first image, or first clone. Here's Grant and Kathy's one, and here's my original database. Over here, we were running against that original database. Let me pop over here and say, let's run that against this masking set. We can see values have changed here. Right? I've changed the names. If I scroll over, male and females are done correctly. My emails are changed. So here, that's Saeed Vesterine, and so it's S. Vesterine here. Slaps that example. Completely different, right? I've got telephone numbers that are different. Anything that I put into my masking set has been applied to the image process, and then it flows through to the clones as well. When I build this process, I could do it automated, I could do it by hand, but more importantly, I could set permissions. So one of the things that we allow you to do is we do some permissioning. We have 3 different roles for now where you can be an administrator, you can create images and clones, or just clones. So for developers, they likely would be chosen to just create clones. For DBAs and admins, they would be standard or admin, allow them to work with that. We realize some of you would like per machine or per instance permissions, and if that's the case, please, we would love for you to click the send feedback or send a note to Redgate and say, I really need this. But I urge you to give this a try and take a look at how this might help you out as well. There's a number of features and it's really a fantastic tool that changes the way I develop software. So as I work with databases now, I do whatever I want, and then I can drop and recreate a clone to get back to my base and move forward. And then periodically, I can create new images as needed. I could certainly create new images every night or every week and distribute them on a regular basis to developers or allow them self-service or however that works. Now just to show you that that actually works, I'm going to show you something else. I want to change my domains. This is my SLD file, so I'm going to get rid of the invalid and we're going to make that way out west. I'll save this and I'm actually going to run my script again. And we'll see it'll drop those clones and it'll rebuild my image and it'll rebuild my clones again. Now typically I would have this separate process. I would rebuild images or make new images and then separately deploy clones. But for the sake of time and trying to have it happen in this demo, I'm putting it all together. So I'll take a few minutes and I'll have that done. And then once that's done, all of my emails should be in one of these domains. And if I flip back and look at this while this is running, we'll see that example.org.redgate.invalid, these are all emails, domains that were built as part of the masking process. Since I altered my masking process, I should have a new set here in a moment. When my clone becomes live, we'll be able to do that. And so it is, and let's see. So if I look now, I actually have a new domain here, the one that I just added to my list. And that's a fantastic way that I can customize things. I did that by just altering the dataset file. And we give you all of these, so you have the ability to look at all these files. These DMDSs are the ones that we provide, but we take these UDEF files. In this case, this was the SLDs one that one of our sales engineers here created. We just added a new file to this particular folder, and then it's available for DataMasker to use however you want. And let's pop back over here. So ultimately, our whole goal here is we want to create, protect, and manage all of the database copies that we have. We want to ensure that while we're moving fast in DevOps process, that we're doing so in a secure manner, in a way that works really well. And we want to take all these items, and I think our SQL Provision product actually does this, right? That we reduce the amount of tickets that have to flow between developers and DBAs and SAN people and everybody else, because we want to accelerate the delivery and we don't want anybody to block anybody else. So we want, as much as possible, people to self-service their work. We want to give them the choice to do it through something like the interface, the web interface that we have, or through Powershell, some kind of automation, so that it can become part of any process that we have. We certainly don't want to juggle disk space. I've done that for years, and it's always a pain, and nobody's ever happy with the way we juggle disk space. But by using something like SQL Clone, you have the ability to rapidly provision much larger images or much larger databases for people without actually requiring that disk space. There's a number of products and companies and ideas around this, including containers and virtualization, but I think SQL Clone is one of the best solutions for the value out there. And then we have to make sure that as we provision these copies of databases, we're doing so in a safe manner. So we have to sanitize, anonymize, pseudonymize all that data. And DataMasker allows you to do that. And so I think it's a fantastic way of doing this. And then certainly we want to make realistic environments. And that's what SQL Clone and DataMasker allow us to do. We get the size, shape, and similar skew of data because we can control exactly how the sanitization works. But we give developers this production-like database that is useful in the application, with all the edge cases of data, all the nulls, all the ranges of dates and numbers and IPs and names and everything else they could need. Because ultimately what we're trying to do with DevOps is we're trying to shift to left. We're trying to move anything we can discover to earlier in the process. Just like we know that if we could learn about a bug in testing rather than production, it's better. And if we learned about it in development before testing, then that's even better. So we're trying to shift everything left by giving you data that's realistic, is very close to what you really need, but isn't sensitive, isn't the actual data from production. And then of course, when we want to manage this process, we need a central view of everything that's out there. So whatever way that you do this, you have to make sure you have some central view that has auditing and reports and lets you know exactly what happened. And SQL Provision does this. So whatever solution you want to choose, and I would love for it to be SQL Provision from Redgate, you have to make sure that it does this. Ultimately, we want to move fast and keep your data safe. So as you move to a DevOps process and as you incorporate the database in your DevOps process, you want to make sure that you do it in a safe manner. And the SQL Provision and our SQL Data Privacy Suite both will help you do that, help you discover your data, where it is, classify it, protect it, and then certainly if you use the Data Privacy Suite, then you'll be able to monitor it moving forward as well. So that's most of what I have here. If you've got feedback, please let us know. The SQL Provision at redgate.com and the Redgate Hub at redgate.com/hub are some great places for you to get more information. We're constantly publishing new things, and I'm really looking forward to adding in a bunch more articles on data masking, especially because there are all these strange cases that people will need to solve or people need to work with. So we want to give you information about that. If you want to get a hold of me, please feel free. And I know we've got a few questions, so I want to take a few minutes to go over some of those before we leave. So somebody's asking, does the image always have to persist or the clone have to be connected? They actually do, because the way this works is similar to how a database snapshot works or how a virtual disk works, is that we mount that image for the majority of the data. And so your clone will read from that image where appropriate, and then any changes you make are written into a very small differencing file that exists on your machine. Now, obviously, if you updated every bit of data in the database, every page, your difference file would look the same size as the original database. But for development, we rarely do that. We update some piece of it, and then we'll reset and start over again. So the image and the clone are always connected, but because that image can be shared by multiple developers, it actually dramatically reduces disk space. So if I have a 10 terabyte image, I could have 100 developers hitting that image, and that means each of them would share that 10 terabytes, and they would only have a few hundred megabytes on their own machine. So somebody else is asking about the Data Masker tool. Does it actually store insensitive data? And it really doesn't. And that was one of the things I was concerned about when I first saw this product. But I realized as we went through the way it works in the architecture, the data masking tool actually is applied to your database. So when I run it now, let me just pop over here. If I were to click run this rule, this masks the data in place. So it actually affects my database. So when I'm testing this, I test it on a clone because when I make a mistake, I want to be able to reset it. This is applying it in process. So when we're building that image, we actually apply it to the image before it's written to disk. So sensitive data never, as it's read before, into memory, we apply data masking to it, and then as we write it out to disk, it's been changed. So no sensitive data actually moves. And that's the only other question. Somebody asked, do we mask the data on the way to the cloner image? We mask it on the way to the image. So all the developers that create clones off of that image will have masked data, and there's no sensitive data there. I think when you try it and you look at it, you'll be impressed. It really does a fantastic job, and it's architected in a way that just makes sense. Kind of the way that I would naturally think to do it. Excuse me. Talking here for a while today. So somebody else asked, is this different from dynamic data masking in SQL Server? It is, because in dynamic data masking, the original data is in the database, and as the query is satisfied, the data is masked before it's sent to the client. So the original data exists in the database. In this case, the original data is changed before it gets to the database or in the database. So any client tool, any client tool, somebody's going to bring me water in a minute, I think. Sorry, it's been a very long day. Thank you. All right. Any query, any client tool, anything that reads that data will get what's in the database. So data masking doesn't actually prevent things. It just obfuscates them. And I've written a series on SQL Server Central. There's a stairway about this. There's a few other articles that will show you that it's fairly trivial to kind of derive what the original data is from dynamic data masking. That's not the case here with Data Masker. It will actually change the data as it's written in the tables, or if you're using SQL Clone and SQL Provision, it'll mask it going into the image, so there's no chance of release, which is not the case with dynamic data masking. Dynamic data masking is really a application convenience tool. It makes it easy to program. It is not a security feature and does not actually protect that data. And I've got one more question here. Somebody's asking, how is this different from SQL Server snapshots? Well, it's actually closer to the scalable shared databases that SQL Server did, where you could share an MDF across multiple instances, a feature that I think had promise and never took off. But in this case, a database snapshot is a copy on write. So as I change data, we copy the original one into a snapshot file. This is kind of the reverse, where everything exists in the original file, and as I change it, we copy it to the difference file. So the changes are in a difference file. It's similar, but in fact, because we can read and write to these snapshots easily, we can drop them and recreate them. There's no dependency on another database. There's a dependency on the image only, which is something on a file share that you create. That's the difference. And so I think in many ways, this is a much better tool for development than database snapshots, but feel differently, please let me know, and I'd love to be able to chance to talk to you and see if I'm right or you're wrong, either way. So that's about all I have for now, and we've got a quick comfort break coming up where you have a few minutes to get some coffee, get some water, which I need, use the restroom. And then Kathy Kellenberger, who's our editor of Simple Talk, and Ben Emmett, who's a product manager for SQL Monitor, they're going to come back and talk to you about how great DBAs manage your day. And they're going to show you how you deal with large, complex environments, how you meet the challenges that you'll face on a regular basis. So hopefully you've enjoyed SQL in the City here and talking about SQL Provision, so how you can manage your databases and test and development environments. If you've got questions, please feel free to get a hold of me. And otherwise, have a great day, and thanks for watching SQL in the City.